By now we know that the two covalent bonds in water are very, very polar, and this makes water a polar molecule. That is one of the important features of the unusual characteristics of water. Another unusual feature is a type of bonding known as hydrogen bonding. Now, the bonding that occurs in a water molecule, that covalent bonding, is known as intramolecular. It occurs within a molecule. Whereas hydrogen bonding is a type of bonding that occurs between molecules. Now, hydrogen bonding occurs when an electrical attraction, so that just means the attraction between a positive and a negative, and it can be a partial positive and a partial negative, between a hydrogen atom that must be in a polar bond with nitrogen, oxygen, or fluorine. So anytime a hydrogen directly bonds with nitrogen, oxygen, or fluorine, hydrogen bonding can occur. So that's the case with water. Now, I just want to point out that hydrogen bonding can be a little confusing. Just because hydrogen is in a bond, it does not mean it will hydrogen bond. For example, carbon-hydrogen bonds never hydrogen bond. Hydrogen bond is a special type of intermolecular force that occurs only when hydrogen is covalently bonded to nitrogen, oxygen, or fluorine. And there are two ways that we think about this hydrogen bonding. We think of hydrogen bonding donors and acceptor. And the donor is going to have the partial positive charge, and the acceptor is going to have the partial negative charge. So hydrogen bond donors are the hydrogen atoms with a partial positive charge that are covalently bonded to nitrogen, oxygen, or fluorine. So the hydrogen has a partial positive charge. Hydrogen bond acceptors are molecules that have nitrogen, oxygen, or fluorine with a partial negative charge, which happens a lot because these atoms are highly electronegative. So it can get a little complex because an acceptor doesn't have to be a donor, but for water, it's both. Water is both a donor because it has the hydrogen with a partial positive, and an acceptor because it has the oxygen with a partial negative. So water has an ability to hydrogen bond really effectively because each lone pair is able to act as an acceptor. Each lone pair on the oxygen is able to act as an acceptor, and it has two hydrogens which are able to act as donors. And typically we illustrate or signify or model this intermolecular force, this force between molecules, as a dotted or dashed line, whereas the intramolecular, the covalent bonds, are signified by a solid line. So we see that each water molecule is able to hydrogen bond with 4 other water molecules, and because the molecular structure of the 4 electron pairs around oxygen is in a tetrahedral arrangement, then each water molecule can engage in a tetrahedral arrangement with other water molecules. And this gives it a lot of stability. This interaction, this hydrogen bonding that keeps water molecules together is incredibly, incredibly strong for an intermolecular force. Now, it's only about 5% of the strength of a covalent bond, but it's strong enough to keep water as a liquid at room temperature while all other molecules that have similar molecular masses as water are gases. So let's take a look at hydrogen bonding in the 3 different phases. When water is in the solid form, which we of course we call ice, each water molecule, is tetrahedrally bonded, hydrogen bonded to 4 other water molecules, and they expand from the liquid water phase to become less dense. So solid water is less dense because the hydrogen bonding is slightly longer in the ice than it is in water. In water, there's definitely hydrogen bonding keeping those water molecules together. That's how it exists as a liquid. But the structures are more fluid because those water molecules are moving much more quickly than they are in the solid phase. And in the gas phase, which we often will call steam and sometimes water vapor, there's no structure at all. The water molecules are all very, very far apart and they are not interacting with one another. They may collide with one another, but they'll just bounce off.